right? All right, so for exponential growth, we have key points, and you're going to be asked to write down those key points. The key points are very easy. The first one is always 0, comma, and we have to find out the y. And the second point is always 1, comma, and we have to find out the y. If I know x is 0, how do I find y? You plug it into the equation. So if the equation, this one is f of x equals b to the x, and I put 0 in, what is anything to the 0 power? 1. And if I put 1 in, f of 1 equals b to the first. If I put 1 in, then I get b. Whatever value b is, it will be a number. That's what I would put in that spot. So you would be asked to find key points. You will be asked to find asymptotes. And if there is no shift, up or down, then the asymptote is always going to be y equals 0. This line right here. Oh, I'm sorry, I didn't say what an asymptote is, did I? You all know what an asymptote is? Probably. Okay. So remember with the Brownie question, remember how you were saying it cannot equal 0. So an asymptote is kind of like a border, a wall, where this graph, it's going to get really close to that wall and it's going to go along that wall, but it is never going to pass through that wall. It's never going to equal 0. So you can see my graph right here. It's going closer and closer to this x-axis where y equals 0, but it never crosses through it. It just keeps going along it. It never equals 0. With the Brownie question, we just have less and less and less and less brownies, but we never have 0 brownies. So that is what an asymptote is, just kind of like a big old cage, a wall, can't get through. Another thing you'll be asked to write about is the domain. And the domain, remember, is the x value. So for this function, it goes all the way to the left and all the way to the right. So what is the domain? Oops, that's not the color I meant. Domain is all real numbers. And then the range is from low to high. So what's the lowest value? It's just above 0. It doesn't equal 0. So you write for the range, you write y is greater than 0. You don't write greater than or equal to. You write greater than because it can't equal to. Okay, and you're going to see that over and over and over again. Yes?
Can it touch it but not go through it?
It cannot touch it. So remember the Brownie question? I can't have 0 brownies because they just keep halving the amount I have. It's going to be super small. Okay, so now if we have decay, the graph goes down. It's very similar to growth, except for the graph is going the other direction. So we have we have the decay factor. It's the same equation, it's just that this time b is less than 1 but greater than 0. So the b value in the equation, if it's between 0 and 1, then it will be a decay question. Like my Brownie question was decay, it's because my b value was 1/2. I kept multiplying by 1/2. If not, if there's a shift or a stretch. So if it is just f of x equals b to the x, then that would be true. Okay, so our key points, we first plug in 0. And for this particular equation, when we plug in 0, we get 1. And then after that, we plug in 1. So you plug in 0, and then you plug in 1, and that gives you your key points. And for this, f of x equals b to the x, when I plug in 1, I just get b. but I don't know what b is. We'll do one that actually has numbers in it next. You will have to write down the asymptote, and if you're looking at the picture, the asymptote, that wall that it cannot cross, is the same as the other one. The asymptote is y equals 0. That's the asymptote. And then it says the domain is all real numbers, and the range is y equals, or is greater than 0. It's the same as the other one. So let's do a bunch of examples so we can get this stuck in our head before we ever add on shifting and stretching. So example 1, we've got y equals 2 to the x. This is similar to the money question, where we're doubling it every time. So our key points, what do we plug in? We plug in 0, and we plug in 1. So let's plug in 0. Y equals 2 to the 0. It's anything to the 0 power. 1. Our other key point, we're going to plug in 1. Y equals 2 to the first. What do we get? 2. And we graph those. 0, 1, 1, 2. There's a part I forgot to answer already. Is it exponential growth or exponential decay? What is our B value? 2 is our B value. Is that between 0 and 1, or is it greater than 1? So this is exponential growth. Oh, hey. Exponential growth. So if it's exponential growth, I know that my graph is going to be growing up. So I can connect my dots now. I also know there's an asymptote where? At y equals 0, which is the x-axis. So as I'm connecting my points, I'm going to make sure that I do not pass that asymptote. You cannot pass the asymptote. Now, if you needed more accurate points, how could we get more points than just those two? You could use your graphing calculator. You could also plug in more numbers for x. Either would be fine. All right, 2 more questions. Domain and range. Domain? All real numbers. Range? Y is greater than 0. No equal to. Just greater than. Until we have a shift. Because that asymptote, once I have a shift, like up 3, the asymptote's going to move up 3, the graph is move up 3, so yeah. All right, this one we've got exponential growth or decay. What is our B value? Half. So that is a B that is less than 1 but greater than 0. So this is decay. That tells us that our graph is going to look like a decay where it starts really big and it goes down really, really small, but it does not cross the asymptote. Where's our asymptote going to be? Y equals 0. All right, key points. We plug in what number first? 0. Plug in 0. With all of these graphs, the sooner you realize this, the better. With all of these graphs that we're doing this entire year, we're always plugging in 0 for x to find the y-intercept. We're doing it with all of them. So let's plug in 0 for x. We get y equals 1/2 to the 0 power. What's anything to the 0 power? 1. Then we plug in y equals 1/2 to the, what's the other number we need to plug in for x? 1. So you plug in 0, then you plug in 1. 1/2 to the first is half. So I'm going to graph those. 0, 1, and then 1.5. You see it's getting lower? Yes.
Are you only gonna have one asymptote?
Yes. For these graphs. So since I know where the asymptote is, and I know those 2 key points, I can kind of just approximate my graph, and if I want more accuracy, I'll plug into my calculator and get more accuracy. All right, there. Oh, I forgot domain and range. What's my domain? All real numbers. What's my range? Y is greater than 0. Go ahead and take about 4 minutes, and you answer the next 4. You're saying if it's decay, you're saying if it's growth, you're finding your key points, you're finding your asymptote, you're finding your domain, and your range. And graphing it. Oh my gosh, so much. I think we've done way more work in here before. This isn't too bad. Are you talking about at -1? Because -1 is the fraction. Right, and until we have like a +4 at the end. Which is not, we're not gonna do the shifting until 6-4, I think. So we're just practicing kind of regular graphs. Tomorrow we'll learn about the natural number. And on Monday we'll learn about logarithms. I know, it's gonna be like the first thing that we do in here that you probably never see. Except for Santoro apparently does it is. Oh, he chemistry.
I'll say.
But can you explain to me what logarithms are? Thanks, Julie. What about natural log? Do you do natural log too? LN? We'll learn that too. All right, let's look at this together. I filled out some of it, but I did not finish. So you guys help me with the rest of this. Nick, key points number 1. Hey, I'm putting somebody on the spot. Let's be respectful and listen when they're talking. So 0, 1, and 1, 4. You guys get, well, I gotta zoom in. This is not working. You guys agree with Nick, or would you politely disagree with his choice in key points?
I agree.
Good.
I agree.
Me too. So this one, the exponential, it shoots way up really fast. What made it go up really, really fast besides the fact that it's exponential? What do you think?
The 4.
The 4. Yeah. All right. And then the next one, if I can turn the page. All right. Dave, key points. 1 and then 2/3. So we graph 0, 1, and then 1, 2/3. This is a decay. So when I connect it, that's not very accurate. You could probably do more accuracy with a calculator. It's pretty close though, huh? I got my exponential skills on. All right, good. Next one. This one is also decay. Walt, what'd you get for key points? Number 3. Yeah. 0, 1. And 1, 2.5. Is that what he said? Okay, so we connect those, 0, 1, and then 1, 2.5. All right, last one. This one is a growth. Lily, can you tell me the key points? 0, 1. 1 and then 1.5. 0, 1, and then 1, 1.5. And it's growth, so we see that it's going up. All right, we feeling good about this stuff? Okay, everything else is real life applications of exponential functions. So here's where we really need to like read the problem and use the formulas. Here we go. So we have 2 models. We've got an exponential growth model and an exponential decay model. There's only one difference.
Plus or minus?
If it's growing, it's plus. If it's subtraction, it's minus. The growth factor, remember the growth factor, B has to be greater than 1. So it has to be 1 plus something. And the decay factor, B is between 1 and 0. So to get that decay factor, it's 1 minus something. But what we have here is we have a rate. Where would you see rates in real life? Percent rates. Interest rates. Yeah. That's like a big one. So you really need to understand how it's calculated so you know what kind of money you need to come up with when you are buying stuff. Or you need to know how much money or what interest rate you need to save however much money, I don't know, all that stuff. Bank things. Okay. So the interest rate, you would add 1 if it's growing, or the interest rate, you would take 1 minus the interest rate if it was something that would go down. Do you know something that grows with interest rate? Is there something in real life when you put money in the bank? Put money in the bank, but it grows really, really, really slow.
Is it like 0.01?
I don't know, it's really low.
It's 0.002 usually.
Yeah, it's really low. Something else that maybe you're aware of, maybe you're not aware of, is a lot of times your houses, like if you own a house, well they appreciate as long as you're in a neighborhood, as long as you're in a good neighborhood that has good schools, your house value will increase. And it's usually around 3% per year. That's kind of like an average. But if you're in a bad area with bad schools, it's probably not going to appreciate. So it kind of depends on where you live, but usually they do appreciate. What's something that goes down in value? Like, yeah, and do you know what that's called? Starts with D. Depreciation, right? That goes down maybe 1%. What?
Machinery.
Oh, machinery, yeah, like hospital machines, when they buy it, it costs, $100,000, and then a few years later, it's not worth that much. Even your phones, like if you go to sell it, you're not getting what you paid for. Okay, so here's a real life problem. The value of a car in thousands of dollars can be approximated by the model y equals 25 multiplied by 0.85 to the t, where t is the number of years since the car was new. Okay, I want us to pay attention to something about this word problem that might mess you up. I'm going to read it carefully. The value of the car y in thousands of dollars. That is saying that y is per thousand. Okay? Tell whether the model represents exponential growth or exponential decay. So there's two values. This is the exponential equation. We need the b value. What's the b value? It's 0.85. So is 0.85 growth or decay? That's decay. And then we also think about it, and we just talked about, don't cars go down in value? Identify the annual % increase or decrease in the value of the car. So the annual increase or decrease, that is going to be our R. We need to find the rate. Okay, and to find that R, we're using the formula that was on that previous page that said y equals, was it an A? A times 1 minus R to the t. And we're going to set that up so it looks like this, 25 times 0.85 to the t. And when I set it up that way, you can see these two things. These two things are equivalent to each other. So I'm going to set them equivalent to each other. So I'm trying to find the R. I know my B value is 0.85, but I'm trying to find what rate it is decreasing by per year. How do we find it? Or do you have the answer? You subtract 1. Okay, if I subtract 1, I get negative R equals negative 0.15. That's not what I do, but you could multiply both sides by negative 1. You could divide both sides by negative 1. So I get that R is 0.15. What am I trying to find? Question B. Identify the annual % increase or decrease in the value of the car. I'm trying to find a percent. How are you making that into 15%? Right. To find percent, we need to take that answer and times it by 100. Just like we do when we find our homework grades all the time. Those of you that do your homework. So that would be a 15% annual increase. Then we have to estimate the when the car will be $8,000. So I'm going to use my formula for C. And I'm going to say $8,000. Hold on, I'm not going to say that. Because what's Y represent? Thousands. So I'm actually, go ahead. I'm just going to say 8 equals 25, 0.85 to the t. So how am I going to solve for that?
Divide by 25.
Okay, we can divide by 25. we'll cancel that out. This is probably something like a decimal, but I'm just gonna leave it as a fraction for right now. It's probably a decimal. How am I gonna solve for that?
There's some way, I don't exactly know how, but you can use one, some kind of log scale to get that by itself, I don't know how though.
All right. So if you don't know what logs are, how are you gonna solve for this? Okay, so there is a way to solve for t we haven't learned yet. We're not learning until next week. So what are we gonna do?
Leave it.
No, we're going to find an approximate answer. How are we gonna do it?
Square t.
You can't take the t through when you don't know what t is. All right. Get out your graphing calculator. And let's go to y equals. And I'm just going to type in